Hello everyone, and this is Tuesday's lesson on Surds, and we're going to we've got two videos to watch, and we're going to look at rationalizing Surds. Now, if you know how to do this and you remember it from like earlier in the year, then feel free to skip to the questions that I want you to do. Otherwise, carry on watching. Okay, so we're going to look at the easy type ones here first, and then we'll look at the difficult type ones in the next video. Okay, first of all, what is rationalizing surds all about? It's an important skill, and if you ever kind of do A-level maths and so on, it's a really useful skill, and it's a pretty important technique for like further problems you're going to be doing later on in maths. And in essence, really, when we're doing calculations, we don't like having surds on the bottom of a fraction, and it's all about eliminating that surd from the bottom of a fraction. And it's an old-fashioned skill in some sense because it's geared up for working things out without a calculator. And again, it's just the principle that it's easier if you don't have a surd on the bottom of a fraction. So it's about eliminating that surd from the bottom of the fraction. And let's talk about how to do that with these easy type ones. We're going to do these three examples here now. Okay, so here, for example, we've got 3 over root 2. And what we want to do is we want to change the appearance of this fraction. Not its value, we just want to make it look different. But we want it in such a way that there is no surd on the bottom of the fraction. So for example, like 4/8 is the same as a half, isn't it? They're both the same fraction, but one simplified. We're kind of doing that again with this sort of thing. Okay, so how do we do that? Okay, and it's a really, really easy technique. Okay, on the bottom of the fraction is root 2, and all we're going to do is multiply top and bottom of this fraction by root 2. And if you think about it, really, it doesn't really change the fraction itself, but it is going to change its appearance. So for example, if I had 5 over... Actually, why if I picked 5? If I had something like 3 over 5, if I multiply top and bottom by 2, like this, then I would get 6 over 10. But that is still equivalent to 3/5. They're the same fraction, aren't they? They're just equivalent fractions. So that's what we're doing here. We're multiplying top and bottom by root 2. But the way I've written it is I've written multiplying it by root 2 over root 2. But remember, when you multiply fractions, you multiply tops with tops, bottom with bottom. So that's kind of like what we're doing here. But effectively, we're multiplying by 1 if you think about it. This thing that I've written here is just 1. Okay, so if we multiply the tops, we get 3 root 2. And on the bottom, we get root 2 times root 2, which is root 4. But this is why we've done that, is because on the bottom, root 4 just turns into, well, square root of 4 is 2. So this is it. Okay, so on the top, we get 3 root 2. On the bottom, we just get the integer 2. And I'm telling you that this is equivalent to 3 over root 2. They are both exactly the same fraction. They're both the same, but this is the simplified version. And the thing is, though, your Casio calculators are quite cool. If you type that in, it will probably turn it into that. But remember, this is kind of like the non-calculator skill, so you'd be doing this on a non-calculator paper a lot. So we say that this is the rationalized version of this fraction here. Okay, they're both the same fraction, but the one on the right is rationalized, the one on the left isn't. Okay, and it's all about getting rid of that surd from the bottom of the fraction. Okay, so let's do the one here. So root 5 over root 2, and we're going to multiply it by, well, I like to write root 2 over root 2, but effectively we're multiplying top and bottom by root 2 over root 2. Okay, so we're just multiplying the top and the bottom of that fraction by root 2. So it's going to be root 10 on the top, because remember it's root 5 times root 2, so they're both surds, that turns into root 10. And on the bottom, root 2 times root 2 is root 4. And lo and behold, on the bottom, we get the number 2, because the square root of 4 is 2. So this is the answer, is root 10 over 2. And there isn't really much I can do with that. I can't simplify the top. There's no square number that goes into 10. 4 doesn't go into it, blah, blah, blah. So there isn't really much I can do. 2 doesn't go into it. Square root of 2, I forgot, I'm getting my words muddled up. But there's no square number that goes into 10, so there isn't anything I can do. Okay, let's do the last one. Okay, now it's important to realize that we only really care about the surd. Okay, we don't care about anything else other than the surd on the bottom. So I see lots of students multiplying top and bottom by root 3, which will still give you the right answer, but you're making extra work for yourself. So what I'm going to do, I see lots of students multiplying by 2 root 3, which is not the best practice. You're going to cause extra work. The best thing to do is multiply top and bottom by root 3, because we only care about that surd. Okay, now the top multiplied with the top gives you 5 root 3. And the bottom, 2 root 3 times root 3 is 2 root 9. Okay, remember the surd multiplies a surd to give you root 9. Okay, this top stays as it is. There isn't really anything we can do with that. The bottom, okay, root 9 turns into the integer 3. And then we're going to multiply it by the 2. So that turns into 6. So this is a simplified, rationalized version, of that fraction there. And there isn't much else you can do with that. Okay. Now, don't pause the video just yet. Okay, we're going to look at this one here. This one's a bit tricky. There is a bit to it. Okay, so first of all, we're going to multiply top and bottom by root 3. And the top, when you multiply by root 3, turns into root 15. Okay, so remember, root 5 times root 3 is root 15. The bottom turns into root 9. Okay, so root 3 times root 3. And then the top stays as it is, root 15. And the bottom turns into 3. Okay, because square root of 9 is 3. Now, lots of you might just stop here and think, you know what I've done? I've rationalized that. I've got rid of the surd, and it is gone from the bottom. But you need to look, it's not fully simplified. 6 is an integer, 3 is an integer. 6 divided by 3 is 2, so the final answer is 2 root 15. That is the final answer, okay? Because 6 can be divided by 3. Now, again, you have to be a bit careful because you need to look at the root 15 and think, okay, does any square number go into it? Okay, so 4 doesn't go into it, 9 doesn't go into it. So there isn't any square number that goes into it because you could simplify it further still. So remember, any surds, for example, if it was root 24 or something like that, you know, you can do something with that because it'll be 2 root 6. So remember, look at the surds and see if you can simplify them any further. Okay, have a go at these questions here before you look at the next video and see if you get them right. I'm going to reveal the answer. Oh, and by the way, the last one, I'll put a bracket around it, the top, because it'll make it easier. So, okay, I'm going to reveal the answer. Pause the video, see if you can get them right, and then I'm going to show you the answers. Okay, these are the answers, and I hope you got them. So this is the simplified answers, and the last one though, you can write that as root 2 over 2 plus 1. They are the same. Okay. All right. Thank you for watching this video. You've got one more to watch, which is the difficult rationalizing surd ones. And they are quite tricky, so it's a pretty long video. And thank you anyway. Thank you guys.